Assalamualaikum and hi everyone. Today I would like to explain about my expertise on this topic, which is topic 6, which is about geotechnical tests. There are two types of tests, which known as wind shear test and borehole shear test. These tests are essential for understanding on how soil behave under pressure, which directly impacts how we design the foundations, embankment, and slopes. Both tests are measuring the shear strength, but actually they are used for different types of soil. The wind shear test is specifically designed for soft, cohesive soil, while borehole shear test is more versatile, which applicable to both cohesive and non-cohesionless soil. The parameters measured by wind shear test is to determine the undrained shear strength. Borehole shear test provides a more comprehensive soil profile by determining the in situ shear strength, cohesion, and angle of internal friction. From this perspective, we could say that the borehole shear test involve more complex hardware such as shear plates, pull rods, and a dynamometer, while the wind shear test focus on a rotating wind head. Based on this diagram below, we can see that the left side shows the picture of field shear wind. On the right side, we have the borehole shear test apparatus. Actually, how this test work? For wind shear test, a shear wind is pushed into the soil, and at the desired depth, the wind is rotated until the soil fills. For borehole shear test, it involves a drilling of 76 millimeter diameter 76 millimeter diameter hole, usually vertical, but it also may be inclined or horizontal to a greater depth than the location of interest. The shear head is carefully inserted into the hole to the point where the shear strength is to be measured. The test proceeds by expanding the cylinder half into the soil by applying pressure from the surface through a piping system. Then the cylinder is pulled out with the pulling load and displacement is recorded. Next is for the formula. For wind shear test, to find the undrained shear strength, we use the torque equation, which is T for the maximum torque in kilonewton meter, D for the diameter of the wind in unit meter, H for the height of wind also in meter, and SU represent the undrained shear strength in kilonewton over meter square. For borehole shear test, the result rely on the relationship between normal stress and shear stress. Normal stress is calculated as the applied force over the shear head area. Shear stress is calculated using the pull-out force because it involves two shear heads. Next for the calculations. For wind shear test, using the torque equation, imagine we have a wind with a 60 mm diameter and 120 mm height. If the measured torque at failure is 90 Newton meter, we need to convert the 60 mm and 120 mm into meter. Next, we plug this into our formula so we can calculate the undrained shear strength. And the result is we get the undrained shear strength 113,700 Pascal, or we can convert into 114 kilopascal. That is for wind shear test. We move to borehole shear test. For borehole shear test, we need to take note that the applied pressure to each shear head is similar to the applied pressure from source. So, the applied normal stress at failure can be calculated using formula. From our test data, as the normal stress increased from 30 to 80, as what we can see from the table, we saw a corresponding rise in pull-out force from 152 Newton up to 272 Newton. As two shear heads were utilized, the values of shear stress developed between the shear plates and borehole wall. This can be calculated using the formula of pull-out force over 2 times shear head area. By plotting shear stress and versus normal stress on a graph, we can derive our soil parameters. We can get the value of cohesion. Cohesion, or known as C, this is the y-intercept of our graph. In our sample data, cohesion was determined to be 16 kilopascals, while for the friction angle, this is the gradient of the slope. We can get using formula. We find our angle is approximately to 25 degree. In conclusions, for these both tests, here are some of the benefits if we use both tests. The Wen shear test is favored for being low cost, simple and quick to perform directly in the field for soft clays, while for the Borehole shear test, it can be determined shear strength of soil clay and seed clay. It's usually designed for foundations on soft ground. But borehole shear test is much needed for complex stability analysis of embankment and the design of foundation on soft ground. Choosing the right test ensures the safety and longevity of our engineering structures. So we need to choose wisely between these both tests, which is Wen shear test and borehole shear test, because both have their own both have their own criteria and benefits. Thank you.